we have step 2, 2007, question 1, which is a binomial expansion question. Alright, so I mean, just using that identity, which is in your formula booklet, and you really should know off by heart at the stage, x squared over 2 factorial, blah, 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 blah. And then, that is the 1 plus x to the power of n. So you should be using that, that, whatever. So binomial expansion of that thing there, of 1 plus k over 100 to the half, well, I mean, that's just going to be 1 plus a half times, what is that, k over 100, plus a half, multiplied by minus a half, multiplied by k squared over 10 to the 4, times 1 over 2, so 1 over 2 factorial, plus, well, what's that going to be? That's going to be like, a half, a half, a half again. That's minus 3 times 1 is going to be 3 over 8 times our k cubed over 10 to the 6, and then we have our 1 over 3 factorial. Now, what are we going to do with this thing then? Like, why did they ask us to write it down? There's probably a reason, right? So we want to choose a value k equals 8 to find an approximation. Okay. Well, we want to choose a value k equals 8. Well, how the hell does this have anything to do with that? That's just one of these moments when you're like, what? Like, how does this relate? I bet you're used to this a lot instead. Like, how does this relate? How the flip does this have anything to do with what I just did? Well, this one only requires a little thought in order to get the process. The key is that this is this. So in order to find somehow a root-free approximation, we have to consider this guy. Well, what happens if we set k to be 8? Like, what's going to happen? Well, 1 plus 8 over 100 is going to happen. Now, how does this relate to root-free? Well, another way of writing that is 108 over 100. Okay, and we notice that the bottom line is going to be 10, but the top line actually, well, what is it? Well, not surprisingly, it's 3 times 36. So this simplifies down to 6/10 of root-free. Okay, so that's how it relates. So we know this binomial expansion is going to approximate 6/10 root-free. Because we want to find decimal approximations to it, I mean, it makes the most sense that rather than writing this expression in any old way, I'm going to simplify it down in a very particular way. So that's k, half of k, times 1 over 10 squared. Okay, and this is going to be here minus k squared over 8 times 1 over 10 to the power of 4. Then finally we're going to add, well, what's this going to be? The 3 is going to cancel with the 3 factorial, leaving it 2. So that's going to be k cubed over 16 times 1 over 10 to the 6. The reason why I've done that is because I've left the powers of 10 as they are, rather than writing something like 80,000 or 400 or whatever, is so that this makes it a lot easier to calculate decimal places. Okay? So, setting k equals 8 in this expression, what do I get? K equals 8, implies what? Well, that's 1 plus, that's 2 over 10 squared. Yeah, I'm using k equals 8. So this bit here, 8 squared over 8, it's going to be 8. Minus 8 over 10 to the 4. 8 cubed over 16, well, 8 cubed is 2 to the 9, which is 512, but that's 2 to the 9 over 2 to the 4, which is 2 to the 5, so this is just going to be 32 over 10 to the 6. So that's what we have there. As a decimal, that is what? Well, we have 1 plus, what is that, 0.02 minus 0. Well, let's write this here. So that's obviously 1.02 minus 0.0. Are we sure it's 2? No, not. Sorry, it's 4. My bad. Okay, whatever. So it's 0.0008. So that's going to leave us obviously with 392, and then we're going to append another 32 onto that. So that's it as a decimal, and now that's approximately equal, remember, to 6/10 of root-free. So in order to calculate root-free, all we've got to do is times this dude by 10, and then divide it by 6. times it by 10 is the easy bit, and then we're going to divide that by 6. So, that's just going to be 10.39232 divided by 6. Well, 6 goes into 10 once, remainder 4, that goes in 7 times, remainder 1, 3 times, remainder 1, 4, 1, 0. And we are done. That is our approximation of root 3 to 5 decimal places. And if you notice, if you know root 3 to be approximately 1.73, you're like, holy shit, dude, this is really accurate, okay? That is cool what we just did. Without pen or paper, we found an approximation for a square root, and this possibly gives insight into how a calculator is probably using this mechanism to do such a thing as well. 5 decimal places, cool. Right, now, choosing a suitable intervalager of k, we want to find an approximation for root 6, so we want to do something similar. So let's really take a minute to understand why the first one worked. Why did choosing k equals 8 lead us to a suitable value for root 3? Well, this is because, 100 plus 8, yeah, that's the value we chosen, happened to be a number that was a square number times 3. So therefore, when we took the square root of this number, we ended up getting some multiple of root 3, because root 3 wouldn't go down any further, wouldn't simplify, so it stayed there, the squared came out. So in other words, we want to find some number such that we get some multiple of root 6. So what could that be? Well, what square number times 6 is close to 100, right? What square number times 6 is close to 100? So the first time I thought of this, I thought of 16. Maybe 16 times 6 is close to 100, giving us 96. Now, my intuition immediately told me, hang on, this is less than 100. Oh no, have to go on to the next one. I get 150. Okay, so just choose k to be 50. Right, therefore, if I have 1 plus 50 over 100, that's actually 150 over 100, and when I take the square root of that, I get like, what's that going to be? That's going to be, yeah, therefore 5/10 of the square root of 6, right? And that was perfectly dandy and fine. However, why did I reject the first one? Why did I throw this away? I did this in autopilot. I was doing the question too quickly, and hang on a second. By choosing k to be some big number like 50, aren't we just like making things more difficult for ourselves? Because first of all, when we cube this out, it becomes messy, like really messy. And also, it's not that accurate, right? Because we have a 50 cubed, dude. Like, that's huge, and it will make our expression very not accurate. But surely choosing a small value like k as -4 would work a treat. And in fact, that is the way to do it. One comment I would make about step questions is generally if you find yourself doing like algebra that's just a bit too messy, you're probably not doing it the right way. There's probably an easier way, probably a slightly easier way. So yeah, I mean, I don't know why I rejected 96, because all you have to do in this case is going, minus 4 over 100 to the half, and we consider this. This is clearly 96 over, I'm going 96 over 10, which is was it again 4/10 of root 6. Okay, so let's do that. Take our expression here, and we're going to plug in k equals 4 -4. Sorry, so we have 1 minus 2 squared. Again, minus. Ooh, my mental arithmetic is being tested here. Okay, and then yeah, here we're going to get, because that was 4 squared. It's weird that they're all the same though. Why are they all the same? -4. Yep. Yep. And then yeah, when we're cubing the 4, we get -64, and that's going to give us a -4 over 10 to the 6. Okay, so we have to do that out. So that's actually not too bad. Blah 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 blah. I guess minus 0.02. Then again, we're going to take away 0.000 not 2, and I get to a 0.00004. So which one to do first? It's up to you. Really, it doesn't really make a difference. I guess if we took this dude away first, it makes the most sense, right? Because this would leave us an expression of 0.9999. Yep, let's count the zeros. 9999996. Okay, so there we go. And then it's actually easier to take the 0.002 away and the 0.02 away. So we're left with 0.979796. Interesting number. So what we need to do is times this by 10 and divide by 4 to get our approximation for root 6. So we get 9.79796. Divide by 4, and what will happen? Well, 2 will happen, 1, and then that probably goes in 4 times, 1 left over, 4 times, and then a 3 left over. And that is, what, like 9 times, 1 left over, and then 4 times, 3 left over, and then 9. Right. So that's our approximation to root 6. Okay. All right. So we did both parts there. Now let's go back to the question and look at part 2. So, I mean, this is similar. We want to consider the first 2 terms of binomial expansion of 1 over k over 1000 the cube root, and we want to show that 3029 over 2100 is approximation to cube root of 3. Well, what are the first 2 terms of this? Yep, that's right. Literally first 2. Okay, so that to the third, first 2 terms are 1 plus k over 3000. Okay. Remember, we want to show something is approximately equal, we want to show that approximation to the cube root of 3. So we want the cube root of 3. So, in other words, we want k to be a number such that 1000 plus k over 1000, you can take the cube root of that, and obviously the denominator will become 10, but on the numerator, we want some cube number times root 3. Sorry, times 3. So 3 times some cube number, and we want it to be close to 1000, right? So is there a number such that 3 times this number and this number is cubed is like approximately 1000? Well, yeah. 343 comes into mind, 7 cubed. So it's 3 times 343. Well, that's 3 times 333 plus 3 times 10, which is 30. So that's 99 plus 30. So that's 1029. Okay, 1029. So k is 29 might work. Because if k is 29, what this expression becomes is 1029 over 1000 cube root. What's that going to give us? That's going to give us 7/10 of the cube root of 3. And this will be very similar to this dude here. If k is 29, what's going to happen is we go 3029 over 3000. And we have that these are approximately equal. Okay? Now notice, I want to basically, sorry, there should be another 0 there. I want to basically take this 7/10 and move it over to that side. So a lot of you might times by 10 and divide by 7. But this is actually equivalent to taking that's 3029. What am I doing today? This 3000. It's actually equivalent to just multiplying that by 7/10. Okay? It's approximately equal to 3 root 3. And if we do that, we find out we get, yes, 2100, which is exactly what we wanted in the answer. And that is approximately equal to cube root of 3. So in short, this question wasn't too difficult. As step 2 go, this is probably one of the easiest questions I've ever done in step 2, personally. But don't be disheartened if you don't find it easy, because we all have our personal preferences and stuff. But yeah, it's just there's a few little things that if you don't do, the question will be a lot more difficult. For example, k equals 50 being messy was one of them. And I guess another one is just tailoring your algebraic expressions to what the question is asking you to do. So having those powers of 10 on the outside allowed me to get to the answer a lot more faster than someone, for example, with 80,000s here and 200s and 16 millions and whatever. Okay, so don't fall into the mode of just doing algebraic expressions without actually asking yourself, well, what am I going to use this for once I have this in this format? And secondly, always be double checking intuitions, and if something seems messy, go back and say, is there another way to do this? So thanks for watching, guys. Like, comment, and share, I guess, if you found this useful. Peace out.